So what's up guys? So today we're gonna see a very common problem here. So it's gonna be binary search. So the task I'll just explain the problem real quick. So the task is fairly simple. So we are given array called nums, and we're given a target value. We just have to find the target. We just have to find the index of where the target value exists in the nums array. Okay, sounds very simple, right? But there's a little bit of catch here. The catch is you must write an algorithm that that you have to solve this problem in log and time complexity. Okay, so we're gonna see that algorithm today, and we're gonna just try to solve this problem. Okay, so the logic is so straightforward. Let's just jump right in. Okay, as per the name of the program, the algorithm that we're going to use to solve this problem in logarithm log and time complexity is binary search. So you might heard this problem a lot, and you might heard this algorithm a lot these days. Now the thing is fairly simple. So let's take a look at our inputs. The input I have is, this is a fairly simple array. It consists of 1, 2, 3, 4, 5. So all these numbers. And the main trick case for this problem is, this binary search algorithm will only work if the array is sorted. So if we go to our problem statement, we have given a sorted array in ascending order. Okay. And another part that we didn't cover is, if there is no index, if the number does not exist in that array, then we have to return -1. Okay. So sounds fairly simple. So let's dive into the algorithm. Okay. Here the target value is 2. So obviously in the first index 2 exists. So the output should be 1. Okay. So let's dive into the logic real quick. So have this array element separated. So we have 1, 2, 3, 4, 5 separated. Okay. The logic is fair. The algorithm is fairly simple. They're gonna have 3 pointers. Okay. A start pointer, which is going to be pointing at the starting 0th index as per the starting value. The end pointer is going to be pointing at the last index, and with these start and end pointers, where every single time we're going to calculate the mid pointer. Okay, so how we're going to calculate the mid pointer? Okay, we'll come to that later, but we're going to calculate the mid value with the starting and ending pointer. We're going to calculate the mid pointer, and what we're going to do is, basically, first, the straightforward and brute force approach for this problem is, just iterate through the array, check if the element exists, and return the value. Okay, but the brute force approach will be in the time complexity of order of n, because we'll have to iterate through n elements here. We don't want that. We want it done in log n. Okay, so we're going with the binary search approach. The binary search follows like this. We have a start pointer and end pointer. Each time with the start pointer and end pointer, we calculate the mid pointer, and each time what we do is, we check if the mid pointer is target, if the is the target value. Okay, in our case the target value is 2, and the mid pointer is not the target value. So what we do is, since this is a sorted array, see, we know the target value and we know the mid value. Okay, mid value is 3. Since it is a sorted array, the target value, since the target value is less than the mid value here, as 2 is less than 3, the target value could not be on the right hand side of the array, because since it is sorted, mid value is 3, target value is 2. So since the array is sorted, it only has to be in the left hand part of the array. It could not be on the right hand part. Correct? Okay, since it is sorted, the right hand side will always be greater number than 3. If the target number is less than the mid value, then only the left part of the array has the target value. So since we know this information, we're gonna cut out the entire right side part. So what we're gonna do is, we're gonna move our end pointer to our middle -1. Okay, now in these two we're going to calculate the mid. Okay, if we calculate how, I'll just explain how we're going to calculate the mid. The midpoint is calculated as follow, as I'm going to tell now. To calculate the midpointer of two index, we want to calculate the midpointer between these two, or we want to calculate the midpointer between these two indexes. Since start and end pointers are indexes, what we can do is, we can just, the mid will be always equal to the start pointers index plus end pointers index. If we divide it by 2, if we add both of these and divide by 2, we'll get the mid pointer, mid index. Okay, with that mid index, if you check here, the start index is 0, end index is 1. 0 plus 1 is 1. Okay, 1 by 2 is okay. Now the midpointer will be pointing at 2. So since the midpointer is pointing at 2, we'll check if the midpointer is our target value. In this case, midpointer is equal to our target value. Now we can just return the index of the midpointer. Okay. Let's say it's a different case from now. Okay. Let's just rewind a little bit from the starting. Let's say it's a different case from now. Let's say my ending value is 4. What if I say it's 4? Correct. What if I say it's 4? Now what I can do is I can go now. If it is 4, then we'll do the same thing. We'll check if the mid value is less. Okay, if the target value is less than the mid value, it is not less. Okay, so if it is not less, then it should be definitely in the right hand side of the right hand half of the array. Correct. So what we'll do, we'll just move our start to mid plus 1 here. Since we know that this element is not our target element, we don't have to keep our start here. We can just move to the next element. Okay, now we'll calculate mid. Okay, now if we calculate, the 4 sitting at index 3 and 5 sitting at index 4. So 3 plus 4 by 2, if we do the integer division, it will give us 3. So 4 is the mid value. If we come to our mid value here, then if we check mid value is equal to our target, just return the index. So here this algorithm will actually run in log and time complexity. Okay, this is binary search algorithm. So we will be doing it in recursion. Okay, so let's carry on to the problem. As I told guys, we'll be trying this problem out in recursion. Recursion is not very complex loops, so we'll just go with the recursion since it is a better way. So I for recursion I'll have a recursive function. So as per for you guys, if you don't know what's recursion clearly, recursion is basically a function calling itself multiple times. Just imagine it like this. So what a loop does, it executes a block of code multiple times, right? Similarly, if you call a function repeatedly inside that function multiple times, it kind of does the same job. Okay. So for the recursive function, I'll have a function called search. So now whatever values problem changes. Okay, whatever value in the problem changes, I have to give as an input to this function as a parameter. So as per our logic here, the mid value is calculated. The start value and end value changes. Okay, between each and every single call. So I'll just have the start and end value here. I'll have S and E as an input. Now here, oh sorry for the bracket. Yeah, now here the next step that you have to follow is we have to in recursion we just have to remember these two things. Okay, first is the base condition. So if you're not clear with the base condition, in a loop you'll have a condition, right? Until that condition is true, you will keep on executing that block of code. If the condition is false, you'll come out, right? Similar case here. If you want to come out, you have to have a base condition where the base condition will hit and you will come out. So we'll just figure out the base condition here. So where we have to stop. Okay, let's say it is a corner case now. Let's say there is no value in this array which is our target. Let's say the target value is something like 6. Okay, there's no value, right? You'll keep on calculating mid. Okay, at one point of time, end pointer will come here and start pointer will move forward. Correct. So now if this happens, then if this happens, then you have checked the entire array and there is no target value. You have to, at this point, you just have to return -1. So this is our corner case here. This is our base condition here. The start pointer, if it is greater than the end pointer now, then we have to return -1. Okay. The next thing is if our mid value nums of mid, for that we just have to calculate mid. So for calculating mid, I'll calculate mid each time. So mid, as I told, mid will be start pointer plus end pointer divided by 2. Okay, now I'll check if my my nums of mid, which will be the middle value, is equal to our target. If it is equal now, then I just have to return the mid value, since I only have to return the index. Now here the next part is we have to check if it is not our target. If the target is not our mid value, then we have to check if the target is in the right hand side of the array or if it is in the left hand side of the array. Okay, so for that I will basically have an if statement here. If our target is less than our my nums of mid value means, then it is in the left hand side of the array. What I have to do? I have to change the end value to, sorry for this mistake, I have to change the end value to mid minus 1. Correct, I have to move the end value here. So for that, let me just, so for this one, since we are doing it recursion, as I told, a recursion is a function calling itself. Okay, so for that we have to call the search function again. So search. Now for the starting value will be the same, but the ending value I am passing at mid minus 1. Okay, now if after this I have to do a small return, so that after this call happens, the value which is getting returned actually it gets returned. So I'll explain this in a moment. Okay, now here, now if suppose our target value is greater than our, if it is in the right hand side, if it is greater than our nums of mid, then similar operation you have to do, we just have to do the search operation. I have to call the same search function, but the start value here will be mid plus 1, ending value will remain the same. Okay, so this, that, let me just remove semicolon which I added by mistake. So here at the last, here for the first time I have to call this search function. So I'm just returning whatever this search function returns in my main function. First time the start value will be 0 and end value will be len of our nums minus 1, since it is 0 based indexing. Okay, so let's see if all the test case pass. As per expected, all the test case passed and we have 100% result out here. Okay, so that's all I have for today, guys. Hope you guys enjoyed the problem and hope you guys are able to solve it. So thank you for watching. See you on the next problem. Bye.